right, so now we're going to look at dot plots, which is another way of displaying numerical data. But let's just put here that it's for numerical discrete data is generally best, because you can see with a dot plot, what we do is we must have a ruled number line. And then what we do is a dot goes above each number. So if you look here, we've got a 22, so I put a dot. And then I have a 19, so I put a dot above that. So what I'm going to show you on the calculator, your calculator, if we had popped that list in, which I have, I've called it data. And if we go to our graph page, which is still this one that has a bar chart, the pink. So if we click on there and I click the list, you can see you automatically get a dot plot. So to save me time, I could then go, all right, I can quickly draw this one. So your dots should be in line with each other. So just be careful with that. So 22 had 4 dots and 23 had 2. And what have we got? 1 for 24 and 1 for 25 and 1 for 20. So 1 for 24, 1 for 25, and 1 for 29. Okay. So there should be, when you think about it here, there should be 13 dots because there was 13 data things. And then what we can do is, even though it's not a histogram as such, you could comment on the shape. So say here, like it's a little bit hard. I might say for this one, it appears symmetric. And you can get away with it. Like, we don't know for sure, but I'm just going to say appears symmetric, and I'm going to call that with an outlier. Okay, so that would be me talking about its shape. Okay, of the distribution. So just to let you know. So if we have a stem and leaf plot, this is another way of displaying data. So a stem and leaf plot is generally split into a stem and then a leaf. So say, for example, if you have the number 15, we put that as the stem is the 10 digits and the leaf is the units, okay, like that. So you must always, so put a big thing here, must always have a key to explain the number. So what I mean by that is that, see how we say example 15 would be a 1 and a 5. That's a key. So see here, they've told me 1-2 equals 12. Because sometimes you might say 1-2 might equal 1.2. So you've got to be very careful. So you must have a key. All right, so we'd be looking for that as a mark. We don't normally use stem and leaf plots for big, large amounts of data because it's not a very good display of it. But if we have, for example, when they say data that's, less than 50, so when they mean that if n was 50, anything above that, we wouldn't probably do a stem and leaf. So we're going to construct a stem and leaf plot. So if you notice, a stem and leaf plot is also it will order the data. Okay, now, obviously, I'd have to go through all the numbers. So if you have a look, this one, if I look for the small numbers, so this is going to be all the numbers that are under 10. So if I look, I've got 2, 5, and 7. Now, they have to be in order from smallest to largest. So 2 would go first, then 5, then 7. So then you'd be looking at all the numbers between 10 and 19. So if we have a look for there, we've got 15, 17, 19, 19, 19, and 18, and another 19. So 15 was my smallest. So that is the first leaf, and it goes under that 2. So you need to make sure that they're lining up, because otherwise the shape won't be correct. So, sorry, we had 18. And then we had 3 19s. Okay, so what this is a good, so this is how we could create a stem and leaf plot. Now this does not have a key, so I need to write a key. You can pick any number, so I can just go 2-7 equals 27. Okay, so it doesn't matter, but you must have a key. Now sometimes doing it and making sure that you collected all the data, you can already see it was a little bit hard for me. I went, oh no, I've missed an 18. So what I suggest you do is pop your list into your calculator. So we'll do that. Pop your list into your calculator and just do a dot plot, and you can just hover over and you'll know what your leaf is. So just so you know, let's have a look. Now they called this marks, so I'm just going to call it marks or whatever. And let's pop in our list. So I had 15 to 24. Just gonna. So the calculator itself does not do a stem and leaf. But what I'm saying is you could take your list and do a dot plot. So if you do a dot plot, and these are sort of like the leaves. So you can see you got 2. And see how we could maybe, let's change our bin settings. Oops, if it lets me. Sorry. So let's go to, oh, it's not going to let me. Okay, so, but we just need to be careful because these are, the axis there is in, not in our tens. So anyway, we've got, what do we've got? What, 15, then we've got 17, and then we've got 1, 18, then 1, 2, 3, 4. So we have actually 4 19s. So I should do that. The next number we've got is 24 and a 24. So 4 and 4. Then I had 25 and 25. So there'd be a 5 and a 5. Then I had 28, 28 and 27. So 8 and 8. Was there any 29s? No. Okay, 1, 30, 33. So 30 is a 0, 33, 37. That's it for that one. So 42, 45, then 52, 55, and 56. 52, 55, and 56. Is that what we all got? Was there 56?
No, 60.
60, sorry. So take that one back. So it was 60, sorry. So we've got that. Now, if you have a look, if you were to turn this on its side, and so what I mean, if you were to turn it on its side and do like this, okay, if you look, we have a thing like that and go like that. So if we have a look, it would look like this. So what type of shape is that data? Good. So this one you would describe the shape as positive skewed. So just be, and that's how we check the shape of a stem and leaf. All right. Okay.